All right, so 2.1 is simplifying algebraic expressions. Um, I would just like to also remind you guys that I would prefer before you go right to the videos that you go through the PowerPoint because there are um, certain things as I'm going through. I'm just kind of doing example problems. So again, if I was teaching the class, in a classroom setting, the first thing I would do is go through the PowerPoint and kind of explain some stuff in the PowerPoint. And then after that, I kind of would always just finish with some examples that I saw on the homework. So when I'm doing these videos, I'm kind of doing them with the assumption that you already viewed the PowerPoint and you're somewhat familiar with some of the stuff that I'll be talking about. So again, just start. I would always recommend starting with the PowerPoint. Again, that you go to Course Tools. Once you get into your My Math Lab, you go to Course Tools, Document Sharing, and you'll see PowerPoints for every lesson. I think all the ones that are shown are all the lessons that make up that first test. And then once you view the PowerPoint, then I would probably get into the actual lesson, actual assignment. And then if you get stuck, kind of go to the videos. So the videos, use the videos as kind of that last ditch effort. Actually, it wouldn't be the last ditch because then if you're still stuck after you watch the videos, if you're not really understanding these problems, then obviously I would attend my office hours. And what I did with the office hours now, I'm just doing them Monday from 6 to 7. So I'd have a full hour, so maybe a little more time if you did need assistance. All right, so let's look at some examples from 2.1. First couple problems, they want you to name the coefficient of the term. So remember, your coefficient is just the number that is in front of the variable. And remember, your variable is your letter. So if our variable is x, what's the number in front of x? In this case, it would be -20. Most of the time, it's going to be pretty self-explanatory. The only times there may be a question, and I'll give you kind of two examples. What would be the coefficient here? Well, all you see is a negative sign in front of it. Remember, there is a number that you just don't see it. That number is actually -1. All right, so your coefficient on that one would just be -1. And then your coefficient here, you don't see anything in front of it, but we know there is in this case, it would be a +1 that's in front of it. So that's pretty much all you're doing with the coefficients. And why they want to make sure you understand why the coefficients are important is when you are combining like terms, and that's really what you're doing in 2.1. You're going to be simplifying expressions, which basically means you're going to combine your like terms. And when you combine your like terms, once you determine that things are like, all you're doing is adding those coefficients together. So all you really look at is the coefficients, and then you put them in front of that like term. So next example would be all right. So first thing we want to do is look at our like terms. And what we know is like terms, they must have the same variable, and those variables must be at the same, they must have the same power. I will tell you with 2.1, all the powers are going to be a power of 1. Okay, so you're not going to see any of these variables squared. So as long as our letters are the same, so we know that 2b is the same, or is a like term to the -9b. And we've already kind of talked about in our previous sessions that when you have numbers, we call those constants, and constants are always like terms as well. So we can combine the 2b with the -9b, and we can combine the -3 with the -7. Okay, so at this point, I kind of reviewed how to do this already. We're kind of beyond that now. So we're just 2b minus 9b is going to give me a 7b. And if you don't know why that is, I would go back and review some of the previous videos where we talk about that. And then a negative 3 minus 7 is going to give me a negative 10. Okay, and sometimes I always say this is the hardest part because you stop here. I cannot combine negative 7b to negative 10 because they are what we call unlike terms. This is a what we call a constant, and this is a negative 7b. Okay, so this has a variable, this does not. I cannot add these two terms together because they are unlike. This would need a b, or this would have to be missing a b in order to combine. So the way they are, we just stop right there. We're done with everything we can do with that problem. All right, the next example. This goes back to that previous item. Sometimes those sections mixed together, but I think 1.8 when we were doing distributed property, and I just kind of want to review that. Remember, you're going to take that negative 3 and multiply it into both things in the equation. So this just gives me negative 3q, negative 27. And again, check to see, can I combine these? I cannot, because at this point they are unlike terms. I'm pretty much done. The reason why they kind of want to introduce that is you're going to see some more examples that are going to deal with distributed property. So this is all one problem that you're going to have to always, you're going to distribute first, and then we're going to combine our like terms. You will see this a lot. I want to make sure a negative in front of a parentheses here. Okay, you're going to see this a lot. And what you must understand is what you're doing is there's a number there. You can't really see it, but it's negative 1. And that negative 1 is going to have to be distributed to both terms inside those parentheses. So not only are we going to have to distribute here, we're going to have to distribute that negative 1 as well. So order of operations, we're going to distribute this one first. We're working left to right. So this just gives me 6x plus 12. And then you could just distribute this right behind it, okay? So negative 1 times 4x gives me negative 4x. And a negative 1 times a, careful here, that's a negative 1 times a negative 6 would give me a positive 6. So again, I'm looking for my like terms. I can combine that 6x and the minus 4x. And then I would combine obviously my constants. And they're both positive here. So 6x take away 4x, it's just going to leave me with 2x. And a positive 12 and a positive 6 is going to give me a positive 18. And I am done there. Let's try one more example similar to that. It's going to be the same type of problem. So once again, I have to distribute there, and I have to distribute, and again, I'm distributing the whole negative 2 value both places. Negative 2 times 5z gives me a negative 10z. Negative 2 times a positive 3 gives me a negative 6. Moving on to this equation here, negative 2 times z is a negative 2z. And again, be careful. We are doing a negative 2 times a negative 6, which would give me a positive 12. Again, I have constants that are like terms that I can combine, and I have variables. We both have z's, I can combine those as well. So negative 10 and a negative 2 would give me a negative 12z. And then a negative 6 plus 12 would give me a positive 6. And again, I cannot combine beyond this point because these are unlike terms once I get here. Let's see. Before we get into distributing the fractions, I'll give you another example here. All right. So always, anytime we see distributed property, it's a pretty good indicator. That's one going to be the first things that you're going to do. Okay. We can't combine these like terms over here because I have to distribute this first. So if you do see a distributed property, like I said, I would go ahead and work on that first. -2 times 2x gives me a -4x. A -2 times a -4 gives me a +8. And then I didn't have to distribute over here. I'm just moving these terms down. Like terms. Your variables, terms, the variables of x. And again, I don't know if it's been stressed, but again, you're adding code. Once you determine these terms are like, you're going to have an x value, and then you're just adding your coefficients. -4 plus 7 gives me a +3. +8 take away 5 just gives me a +3. So your final answer on that one is just 3x plus 6. So again, on these example problems, you're just going to distribute and then combine your like terms. A couple more examples. If you thought you were going to get away with a lesson or an assignment without fractions, I'm sorry. I do have some with fractions, and it also gives me an opportunity to review what's going on right here. And what I like to do when I see that is just so I don't forget, what is that number that's right there in front of this parentheses? That is a -1. Okay, so not only am I going to have to take that 1/3, it's going to have to be distributed into both terms here. I'm going to have to take, and in this case, it's a -1 that's being distributed to both terms. So when I'm distributing a fraction or multiplying a fraction into these numbers, I always like to write these under 1. Okay, make them as kind of your multiplying fraction. So I'm doing 1 times 18, or 1 times 18x, which gives me 18x. And then I'm doing 3 times 1, which would give me 3. Let's go to the next one. This is a negative, so I'm doing 1 times -12, which would give me a -12. And then 3 times 1 gives me a 3. So that's what this looks like. We'll just continue on with this part of the expression. -1 times x would give me a -1x. -1 times a +8 would give me a -8. So that's what it looks like up to this point. Now I want to simplify these two terms. 18 divided by 3 would give me a 6x. And then I'm doing a -12 divided by 3, which gives me a -4. I'm just going to move this down at that point. Then I'm looking for my like terms. So combining your like terms really is kind of like the last thing you want to do on these problems. Really your last step. So 6x take away 1x gives me 5x. -4 and a -8 would give me a -12. So that's it, you're done. So we distributed the fraction, simplified, combine our like terms. I'm gonna do one more, also another one with a fraction. So again, you're going to see that just like you saw here, just like you're going to see it a few times in this lesson. Okay. So again, always remember, we've got a -1, And you're going to take that -1 and we're going to distribute it. Okay, just like we're doing with this fraction here. 1/4, again, I'm going to write those over 1, but 1/4 times 20x is going to give me 20x over 4. 1/4 times -12 gives me a -12 over 4. Distribute the -1. -1 times x gives me -1x. And -1 times a +6 would give me a -6. I'm going to simplify these fractions. 20 divided by 4 would give me 5x. 12 divided by 4 would give me 3. And again, at this point, a lot of these problems combine your like terms. 5x minus 1x gives me 4x. -3 minus 6 will give me a -9. And we are done with that. So that's 10 examples. I think the whole lesson is 20 problems. So you should have an example for each type of problem that you are going to see on 2.1. And just remember, when you're doing these lessons, if there's a problem that you need a little more work on, you can always say, give me another example or give me another problem. The way you get good at math, or the way you get better at math, is repetition. Is just doing these problems over and over again. So if they're easy, that's fine, move on. But if they give you some problems, I would tell you to keep practicing those types of problems, because the more you do it, the better you're going to get at it. Another kind of suggestion, in education, it's been proven the best way that you will learn something is if you can teach it. So if you have a friend or even a child or a sibling that you want to try to explain this to, if you're able to explain it to them, you're more likely to maintain that skill. Okay, a couple suggestions there. So that's pretty much what you're going to see on 2.1, and hopefully you're noticing all these lessons kind of build on the next one. So if you just started, you didn't see any other lessons, and you just started 2.1, you might be a little confused. But as you go along these lessons, they just continue. They add a little bit more to skills that you already should know. All right, and there's 2.1.